this is our project on nanoparticles in solar cells. My name is Marina Elias.
I'm Riley Dietrich.
I'm Josh Emmett.
And I'm Aiden Fraley.
So our first article is about MX scenes for solar cells.
So for the types of nanoparticles in the first article, we have both copper selenide and copper sulfide nanoparticles that serve as activating catalysts in their respective uses. And for the second type, we also have gold nanoparticles, which are used for enhancing conductivity.
Then we have the application of the nanoparticles. The application of the MX scenes in solar cells is very beneficial to the energy sector as it addresses major challenges faced in this area. Four major challenges faced in the energy sector are device performance, stability, high efficient devices, and the usage of clean renewable energy. This is being addressed through the usage of the MX scenes TICT nanoparticles in solar cells. MX in solar cells have been the most effective solution because of its high electrical conductivity and carrier mobility, and excellent transparency. There are two main types of application of MX in solar cells. The first application is additive in perovskite materials. In 2018 was when the first reported addition of TICT into the MAPBI, of which produced an enlarged crystal size. This initiated the exploration of the MX application in solar cells. Furthermore, the TICT additive is very beneficial to speed up the electron transfer. This all allowed for the average power conversion efficiency to increase and improve device performance. The next application is electroid. The properties of TICT MX make it a suitable electroid, allowing for very high electrical conductivity. This overall results in high transparency, flexibility, and adjustable work function.
In this solar cell, the nanoparticles slowed down the nucleation process of MAPBI3. This is shown in part A of the picture on the slide. Due to the slowing of the nucleation process, the resulting crystal was larger and therefore had more surface area to gather light. This improved the power conversion efficiency from 15.18% to 16.8%.
This technology improves upon the current technology for the application in many different ways. Some of the benefits of using MXene nanoparticles in solar cells are that MXene has a metallic conductivity, so it has a high electrical conductivity and carrier mobility. It has enhanced stability under light and in ambient conditions. It has work function turnability. It is more environmentally safe because it is non-toxic and is made in a safer, more sustainable way than current materials, and it's more cost efficient and flexible. Some downsides of current technology are stability issues from light damage, water damage, and heat damage. Environmental and health risks by being made of toxic materials or being made in a non-sustainable way, and it has limited energy efficiency. And the MXC nanoparticles and solar cells improve on all of these.
So our second article is about advances on dye-sensitized solar cells, which are also known as DSSCs, nanostructures, and natural colorant. The types of nanoparticles seen in this article is titanium dioxide. This is a semiconductor used due to its ability to absorb light, and it allows for electron transport in the cell. Then we have silver. These nanoparticles are highly reactive and have high specific chemical behaviors that make it very useful for environmental and technological fields. Then we have BIX zinc 1 minus X oxygen Y. This is a mix of bismuth and zinc and is used as a transparent conductive oxide. Then we have zinc oxide and tin oxide, which have very similar properties to those of titanium dioxide. Lastly, we have Bi2 titanium 2 oxygen 7, which is bismuth titanate. This nanoparticle has the ability to generate reactive oxygen species, making it useful for environmental fields. And this figure shows a typical components of a DSSC and functional mechanisms.
So for the application of these nanoparticles, the issue being addressed is that the normal way to produce solar cells is inexpensive and has negative effects on the environment. And by replacing the silicon that is used in normal solar cells with nanoparticle alternates, it will make them more eco-friendly and cheaper to make. They achieve this by using the nanoparticles to replicate photosynthesis using the photoelectric effect. Photoelectric effect, in essence, is when light hits a metal and it causes electrons to come off of that metal. And in this instance, those electrons that come off can be utilized by us to create energy. Finding a cheaper and more eco-friendly way to utilize solar energy is crucial to providing long-lasting, sustainable energy, which will in turn lead to a better future for all of us.
So what the nanoparticles do, some of the nanoparticles in DSCCs, titanium dioxide is used as a semiconductor, and it's key for light absorption and electron transfer in the solar cells. Some of the nanostructuring techniques used by the nanoparticles are configurations including nanorods, nanotubes, nanowires, and core shell structures. This enhances surface area, light scattering, and electron pathways. One example from the study uses a double layer photonode with a bottom layer of TiO2 nanoparticles and a top layer various TiO2 nanostructures. This configuration achieves efficiencies as high as 9.9%, attributed to the synergistic effects of controlled light and electron transfer. And figure 1 on the right shows the typical components of a DSSC and functional mechanisms, where it goes from photon absorption to electron excitation to current generation.
The photoelectrode of this dye-sensitized solar cell is made up of nanoparticles. The section of the solar cell absorbs the dye and excites an electron into a conduction area. Due to the use of nanoparticles in this conduction area has a larger surface area than most other solar cells and makes it able to carry more of a charge. This gives it a greater efficiency for a lower price, which makes it better than other similar methods.
These are the references that we use throughout this presentation for the MX scenes for solar cells and for our other article. Thanks and gig 'em.